But to get to this stage, we need, as Magnus was saying, we need to bring money in innovation. And today, we need to think how to bring money to robotics. But before going to robotics, I'd like to talk a little bit about disruptive innovations, because it's my field. And today, I'll see how it's important and what does it take, but also what does that mean to invest in disruptive innovation. A lot of very good papers have been written on that, theoretical papers, like you've got the famous S-curve, analyzing the time to market when a new paradigm, technological paradigm, is entering the market. Boom, that's the signal when to invest for a professional investor. You also have the well-known, somehow, Christensen curve on the market readiness and the market penetration of the new disruptive technology. When do people or end investors will begin to buy the products? You also have other marketing strategies like the blue ocean strategy theory, saying that how to address a non-existing market with a brand new product. But this is all theory. How in the real life can we say that it's time to invest in disruptive innovation and how to do it? Well, let me use an allegory first to show you what it takes. So this is, I would say, John. John is an investor. And John is discovering right now in front of you a brand new product. So you can see the sharp eye of the investor looking at something great. This great product coming in the market. It's perfect, it's big, it's strong. John is performing his due diligence. It's totally fitted to the market. It can exactly adapt to what's outside. It answers the need. It's heavy. And that's for him the best thing where they should put the money. And you don't see the head, but it's doing all great things. And within the market, that's the killer application. This is the product to invest in. But somehow, we don't know why. We don't know what happened, but something happened. Suddenly, the product became obsolete. The market just simply disappeared without no reason. It's just a total burnout. And then, a few years later, came another product. And when you look at it, it's, well, the first thing you see is that it's not perfectly fitted to this market, to the environment, to the global market environment. What does it do? What does it take? It's small, it's not really big, but it has this additional thing within it. And suddenly, because of this small piece of intelligence within this new product, then this is the killer application coming here. And this is the intelligence bringing the real product to the market. So what does that mean? It means that shrinking the time window, let's make it clear, I would have invested in the dinosaurs, not in the hairy fellow here. But that's the whole mistake. What does it take when dealing with disruptive innovation is that you need to get out of the box. You don't need to address the market the way you see it right now with the right product to address this given market. You need to favor what I will call serendipity. So serendipity is a trendy word right now. It's very difficult to translate, but we can use like synonyms, like it's a happy accident. It's what Nassim Taleb will call a black swan. It's the unexpected. It's what's happening on the tail of the Gaussian distribution. Low probability to happen, high impact. So this is how, by playing on serendipity, you can identify the happy accident and you can identify the killer application. And for me today, robotics is the best field where serendipity can happen. Why? Simply because robotics is a science of integration. And let me be more precise on that and see what I mean by this. Smartphone, well known. It's no longer, but it was a disruptive innovation. The way you can take pictures, you can surf the internet, the way you can communicate with these kind of systems. Micro piezoelectric actuators. It's well known today, But that was also some kind of disruptive technological innovation. Solar panel and energy management, same thing. Disruptive innovation, quite mature today, I agree. But it's part of the history. The web, open source, the way that the digital intelligence can spread out between people, the way to build intelligence and the way to exchange information. That was quite disruptive. The human brain machine, it's a European project, it's cognitive systems, it's a disruptive innovation to come. It's been under investigation since the 80s, since the first neural networks, but it's still a research field, and that's something to happen. Graphene, that's also a disruptive innovation to come in terms of material, clearly. And I don't put it here, but 3D printing is also a disruptive innovation. But don't forget that, legislation, regulation, that can kill a project, that can be the volcano effect, but that can also push a product to become a real mass market killer application. That can be disruptive innovation. This guy here, by building business model, as being an entrepreneur, is also a disruptive innovation. And this young fellow, by designing the new markets of tomorrow, is also part of the system. And all those past and to come innovations, they all merge within robotics. Why? Because once again, robotics is an integration of different sciences, but also different concepts of business models, regulation, laws, markets to come, and manufacturing processes. So the point is, in this very complex environment, where anything can happen, well, the one good thing can happen where you can identify the killer application. And that's where you need to favor what I call serendipity. But now you can tell me, okay, that's a nice story. I can somehow buy it, but why now? Why today? I mean, we've been talking about robotics for the past 20 years, and I mean service robotics, professional and personal service robotics. So why today? Well, if you look at, we spent more than 20 years investing in new technology, starting from computer science to digital video games and internet, and now robotics. And what we have identified can somehow be summarized in 3 phases. The first one is the emergence of the technology, then the development of the application, and then the third one being the boom of the market. And we state today that robotics, service robotics, professional and personal service robotics, is entering the second phase. And let me give you an example here to somehow try to illustrate more what I'm saying here. Take the computers. At the very beginning of the 80s, it was a geek thing, like it's a machine, we don't really know the use, it has 3-color display, it's a few hundred Ks of memory, it's only geek people, buying it, no real use. Then came the first application, video games. You can play with it, you can learn English with it, even French. So the applications are coming, and then that's the boom of the market. Same thing with the internet. At the beginning, the internet was some kind of very narrow system for military, maybe universities. Few users, very obscure. How does that work? We don't really know. Then the first applications came. You can exchange information between universities. You can find information, and then boom, the market exploded. For robotics, and I mean service robotics, is the same thing. It began 20, 25 years ago with heavy engineered machine to address a very specific need at a very specific use of technology and a very high price. Now, we are seeing that thanks to all the disruptive innovation that service robotics has digested, thanks to what happened with mobile phone, internet, the costs dramatically went down. It means that you can bring a lot more technology at the cheapest price within an integrated system. So now the question is more, what is the use? And based on this question is, what is the amount of technology that we should bring to the product to answer the use? So we are starting now to enter, in terms of market access, this question, what is it that the application is for the system, for the product? Let's look at the use side, the application side. And that's where we say that to identify this use, you need to favor serendipity. And as Erin was saying, serendipity is also bringing the customers with you. And we'll see that later on. So it's between this very complex environment, making sure that now it's the time where, by taking the use into account, you can develop the market. So to do that, we decided at Robolution Capital to create a dedicated product, an expert product to service robotics. And we have, to favor this serendipity, we have 3 different axes. The first one is the one that Dan was describing. It's the Internal Federation Robotics description of service robotics. So it's with a professional side and a personal side. The point here is to say that within different industries, you have opportunities to identify new markets. Let's take an example, 2 examples. That's a discussion I had with Dan yesterday in the car coming from the airport. And he was telling me that in the US, it's amazing to see a very serious general of the military speaking to a very also serious executive member of a toy company and exchanging about humanoids and robots. A military executive and a toy executive trying to identify common use of a product. Wow, if it's not favoring serendipity, what it is? Another example. We are working with a company, it's a French company. They build a small, we'll see it later, a small fish, robotic fish. It's designed to go to swimming pools, like for very wealthy people. They have a lot of time, they have a lot of space and a lot of money, and they are so bored that they buy hundreds of those kind of devices. But analyzing the different other markets, we realized that this fish could be used in nuclear plants, but also in water facilities to test the quality of the water. The technology is the same. It's just a matter to interact, to communicate, and to exchange information from the water environment to the outside. Totally different market, totally different business plan, exactly the same technology. That's serendipity. So that's why looking at service robotics as a whole and exchanging information between different applications and markets is crucial. Second axis is, I would say, the product axis. So it can be integrated products. This is the fish I was talking about. But it's also components. The choice here is to say the disruption and the killer application might not only come from the big integrated stuff, but from one component. Should it be software? Should it be a sensor? Or should it be an actuator? So we need also, as investors, to be ready to invest in each part of the business model. So that's why components, and that's also a matter of serendipity, because it was just like in the internet 15 years ago. Everybody wanted to do the same thing. I mean, they're saying, okay, I'm the new big entrepreneur, I can do everything. That's true, you might be able to do everything. But somehow, if you look deeper, you realize that there is one thing you can do best than the others. And you should then concentrate on this one thing. So from time to time, when I see a robotic entrepreneur saying that, okay, I have this product, I redesign all my operating systems, I have all the middleware layer, I get everything under control, I redesign my actuators and my sensors. The question is to know what is the best thing you do and how can you leverage on that. So that's why we need to look at the components. That's also a source of serendipity. And the last one, it's the famous Rodney Brooks 90%, 10% need of work plus money in the life of the development of the company. When you go from the idea to the production phase, you have the feeling when you start something, when you start a company that, well, gosh, it takes a while before getting the first prototype. But guess what? It takes even more time, even more money, even more work to go to this phase. And along the way, what you have to bring to the company can be totally different at different stages. And that's our third axis. We do not focus only at this level, or we do not focus only at this level, the very seed level, but we look in a pragmatic way at every stage of the companies, meaning a company working on a proof of concept in a very early stage idea might bring a solution to a more mature, so to speak, integrated company. So that's why there also serendipity is needed, and you'll need to be able to see how you can bring those guys to collaborate, to work together, and how you can play on synergies. That's the third axis. So if we come back to this young fella, robotics, we've seen, okay, disruptive innovation, it's all a matter of serendipity, finding the right match between applications, products, maturity of the companies, making this work all together. But what does it take? How do we do that? So starting from here and going back to the components of what is robotics, it means that we have to value each side of what makes a robotics company. It's not only technology, it's not only well-identified parts of the technology, but it's possibly technologies to come that are not yet implemented within the product, but that could kill or make the product evolve. But that's not only that, it's also the law, the legislation, the regulation, and that's a heavy thing in Europe today. How can we have drones flying all over European countries without being stopped because of a regulation issue at the frontier? If I have a farm between France and Germany, if half of my fields are in France and the other half is in Germany, and if I have a drone to inspect the area, and I have some kind of a village in the middle, if the regulation is different between the two countries, how can I use a drone? Impossible. So regulation can kill your product or can help you bring the product to the market. The business models, people, entrepreneurs, there's no product if there's no entrepreneur. But how can they bring this kind of new products to the market? Should it be an upfront cost? Should it be leasing? And more than that, and I come back to Erin's point, how do you put the end user in the loop? Is it a techno-push thing? Is it a market pull thing? No, it's a mix of that. And the end users, in connection with the entrepreneurs, this has to be valued, the connection between two of them. And the new markets. This young fella here, he will be the one buying the new products. When I see my kids playing with iPads or iPhones, it's just amazing. It's natural. And the latest one is 2 years old. It's part of the DNA, I would say. So those kids, they will invent something we don't even think of. Should it be humanoids? I don't know. Maybe it will be humanoids. For me today, I'm not stating that everything in robotics will be humanoids for my kids. I don't know. I'm starting from the use. Today, I want to address robotics based on the use. I need to have something to dismantle a nuclear plant. It will never be a mass market product. Never. Because the environment is dangerous, it needs heavy stuff and robust stuff, so it won't be a mass market. And it won't be a humanoid to do that. It will be a snake arm, kind of. But if I'm addressing also the domestic tasks, vacuum cleaning, today, for me, a vacuum cleaner, it's a Roomba. It's a small thing. It has the intelligence of an oyster, but it does the job. And it's not a humanoid. So I'm not saying that humanoids should be left aside. What I'm saying that humanoid is part of the evolution of robotics. But if you look from the use point of view, from the application, from the future market point of view, We don't care about the shape. We just need to make sure that we have the right product at the right time, with the right amount of technology, at the right cost, with the right end users within the loop. So all of these parameters need to be valued. That's why venture capital, it's about finance. It's about bringing cash to the company. But not only. It's also about finding new manufacturing processes, working on legal, working on marketing issues, and so on and so forth, you name it. It's to bring to an entrepreneur all he needs to make sure that we can achieve altogether a long-term profitability. So, here is the thing, how we work. At Robolution Capital, and it will be somehow my conclusion, we want to be at the center of the ecosystem. We are a private investor. So we are not here to take the position of the industrial or to take the position of the lab, but we want somehow to help all those people collaborate and work together. So being at the core, at the heart of the ecosystem, helps us bringing all those experts, should they come from research labs, from industries, and from public institutions, to work together as facilitator. Then we come to the next phase where when we have this network of experts with us, then we can bring and facilitate the growth of company we invest in because we know what to do and we also have the expertise in our network to do that. And then the last phase is the acceleration phase of a startup. Because of what we've been built together, then we can identify the right market, the right product, and make sure that the company is heading in the right direction. And there is something missing here, which is the European level. I'm very pushing with other people in this room here for what's happening at the European level and what will happen at the robotics public-private partnership in Europe, because it's a strong commitment the European Commission is actually doing in pushing the robotics sector in terms of research, but in terms of applied research and defining new products. So all this is part of the ecosystem. So to finish quickly, what we've seen that investing in disruptive innovations, it's all a matter of serendipity. Get out of the box. Look out for the black swan. Do something that's out of the usual Gaussian distribution. Look at the tails. And that's what we call, or that's what I call, at least, serendipity. And today, the best field in terms of market opportunity to identify that is robotics. And that's why we think that all this together will lead to the next revolution. And for us, this revolution is a Robolution. Thank you.
Thank you, Renaud.